all we're trying to determine here, whether it has a finite sum or not, if you would do this forever, is eventually, will you be adding such a small number, do your terms converge to 0, so that if you were to add this up forever, eventually you'd be adding so little that it wouldn't make a difference. So if we look at part A, what would our R value be for each of our terms? 1 over 4. You're multiplying by 1/4. Can you see that the terms are getting smaller and smaller and smaller? Yes. So this one, we would say it converges, and because it converges, it has a finite sum. If we wanted to estimate what that finite sum is, we could take our formula from before. Our formula for the sum of a geometric series was term 1, 1 minus r to the n over 1 minus r. And if we wanted to get an estimate for what it's going to equal, we would have to put in a large value for n. Because if you just added the first one, that's not going to be a very good estimate. But if you added the first 10, that'll be a better estimate. If you added the first 100, that'll be a better estimate. And so if we let's just add 100 of them up. Term 1 was 1 over 3. 1 minus r was 1/4 to 100 over 1 minus 1/4. Type that whole thing into your calculator all at once. Test yourself, try on your calculator, see if you can get the right value. And did you get a bunch of 4s? And a bunch of 4s repeated would be 0.4 repeated. That would be an estimate for this. This might not be accurate because we only added the first 100. But once you get to the 100th term, you're going to be adding basically 0. Because if we figured out what the 100th term is, it's 0.000000. It's so small already that it's not going to affect much of the answer after that. Yeah, that would be that repeating. Do you know what that is as a fraction? 4 over 9. Good. Okay. Now when we look at part B, what is our R value in part B? What are we multiplying by there?
Wait, how do you figure out what the fraction is?
This 1/4 part or this 0.4 is 4/9? How do I figure that one out? Well, I know that all the repeating ones are always over 9. 0.1 repeated is 1/9. 0.2 is 2/9. 0.3 is 3/9. And so on and so forth. So. Yes, there is. I can show you that after. Okay. So for part B, you can see you're multiplying by 2. Are your numbers in your terms getting closer and closer to 0? No. No. So this one we would say is divergent and does not have a finite sum. Right? Finite means it's a quantity that you have. And finally, for part C here, we go 1/10 minus 1/100th plus 1/1000th. Here, our R value is negative 1/10. And do those numbers get closer and closer to 0? Yes. So this one is convergent. So we can use our formula Sn. How many should we add up this time? You want to do 100 again? Okay. If we do 100 again, we get term 1 was 1/10, correct? Or was it 1? Go up. 1/10. Term 1 was 1/10. 1 minus R is negative 1/10 to the 100. 1 minus 1/10. Type that into our calculator. Oh, I did a typo here, guys, sorry. What was our R value? Was negative 1/10. So I didn't put that. I need to put the negative 1/10 in the brackets there on the bottom. And we get 0.090909, or 0.09 repeating, which is the same as what fraction? 9/99, which is 1/11. Notice that anytime you have a single digit repeating itself over and over again, like 0.2 repeated is 2/9, 0.7 repeated is 7/9. Anytime you have 2 digits repeating themselves, you can make it over 99. 3 digits is over 999, and so on and so forth. So this one being 9/99, you could reduce it to 1/11, which means you could figure out all of your fractions over 11 if you'd like. 3/11 is the same as 27/99, so as a decimal, it would be 0.27 repeated. So you get a fraction over 99. Okay, questions you can do for this one are 3 and 4.